Hi everyone, today we're going to be talking about geometric sequences. So this is an example of a geometric sequence. It goes 3, 6, 12, 24, 48, and so on. So this is a geometric sequence because to get each term, we multiply by 2. So 6 times 2 is 12, 12 times 2 is 24, and 24 times 2 is 48. So you assume that the rest of the sequence will just be multiplied by 2 each time. So a geometric sequence is a sequence where each term is where you multiply a certain fixed number after each term. Or you can divide, which is the same thing as multiplying a fraction. So here's an example, and we're going to try to derive a formula to find the nth term of the sequence. So here we have a1 is 3, and a1, as I stated in my other video on arithmetic sequences, a1 means the first term in the sequence. So a1 is 3, and a2 is 6, which is also equal to 3 times 2. And a3, or the third term in the sequence, is 12, which is 3 times 2 times 2. And the reason why I'm writing it like this is because we need to try to derive a formula, and this is going to help us derive a formula. So a4 is 24, which is 3 times 2 times 2 times 2. So what I'm doing is I'm just multiplying 2 each time. And so we want to find a formula for an. And n is the number of the term you want to find. So an would be the nth term of the sequence. So we realized from here that there's a pattern. We always start with 3, and then we multiply a certain number of 2's each time. So in the first term, we multiply 0 2's. Second, we multiply 1 2. In the third term, we multiply 2 2's, and so on. So it's going to be 3 times 2 to the power of n minus 1. And the reason why we do n minus 1 is because, so for example, the fourth term of the sequence, we multiply 2 to the power of 4 minus 1, which is 3. So 2 times 2 times 2, there are 3 2's there. And in the third term of the sequence, we multiply it 2 times, and so on. So this formula would work for this sequence, but what if we just want to find, a formula in general for a geometric sequence? Well, we have an, and 3 would be the first term of the sequence right here. It's just a1. So a1 times, and 2 is how much we multiply each term of the sequence by. So we're going to call that r. And then last time for the arithmetic we called it d, but for this we call it r. And then we have n minus 1. So this is the formula we're going to use for a geometric sequence. And so I'm just going to write it out. So an is the nth term of the sequence. And a1 is the first term. R is the common ratio. And that's the number we multiply by each time for each term. And n is the number of the term you want to find. Or just the number of the term in general. So, for example, let's say we have 24. In this sequence, that would be the fourth term, so n would equal 4, and an would equal 24. Okay, so we're going to try to use this formula on another sequence right here. So let's say we want to verify that this fourth term of the sequence is actually 3 over 25 using the formula. So we have an equals a1 times r to the power of n minus 1. So we want to find out what an is. And we know so far that a1 is 15. R, we're dividing by 5 each time, so that means we're multiplying by 1 over 5 each time, right? Yes. So r is going to be 1 over 5. And n is going to be 4 because we want to find out the fourth term of the sequence. So a4 equals a1, which is 15, times r, which is 1 over 5, and n minus 1. 4 minus 1 is just 3. So we have 15 times 1 over 125. And then we're going to cancel out the 5, so we have 3 over 25. Then we have 3 over 25. So we just verified that the fourth term of the sequence is actually 3 over 25. So we're going to use this formula to try to solve some problems I have here. So find the eighth term of the sequence, 2, 6, 18, 54, and so on. So we know that A1, the first term of the sequence, is 2. R, the common ratio, we're multiplying 3 each time. So that's going to be 3. And we want to find out the nth term of the sequence. I mean the eighth term of the sequence, so n is going to be 8. So we want to find out an. So we have a8 equals a1 times rn minus 1. So a1 is 2 times r is 3, and n minus 1 is just going to be 7. And we have 2 times 3 to the power of 7 is 2,187. Yeah, I just looked that up. Okay, so 2 times that is going to be 4,374. So the eighth term of the sequence is 4,374. That's going to be our answer. Okay, next problem says, find the 10th term of the sequence, 1, negative 1/2, 1/4, negative 1/8. So it might be weird that we have negatives, but what we're basically doing here is we're multiplying negative 1/2. And the reason why it alternates between negative and positive is because when we multiply two negatives, we have a positive. So we're just multiplying negative 1/2 each time. So r is going to be negative 1/2. And a1, the first term of the sequence, is 1. And we want to find out the 10th term of the sequence. So you want to know a10. So we have the formula an equals a1 times rn minus 1, but we're just going to substitute that with the numbers we know. So we want to find out the 10th term of the sequence, and a1 is going to be 1 times r, which is negative 1/2. And n minus 1 is just going to be 10 minus 1, which is 9. Okay. So here we don't have to really think about the 1, we just have to think about this. And it's going to be a negative because we're taking to the power of an odd number. So 1 to the power of 9 is just going to be 1, and 2 to the power of 9, which is 1 over 512. Yes, I looked that up. Okay, that's our answer. Negative 1 over 512. That's going to be the 10th term of the sequence. Okay, how many terms in the sequence 3, 3 over 2, 3/4, 3/8, all the way to 3 over 32? So we know that a1 is going to be 3. And we want to find out how many terms in the sequence. So we know that this is the first term, this is the second term, third term, fourth term, and this is going to be the nth term. So the number n, the number for n will tell us how many terms are in the sequence. So we want to find out n. But we know that the nth term is going to be 3 over 32. And we know that r is where we are multiplying by 1/2 each time. So it's going to be 1/2. So we're going to write the formula. An equals a1 times rn minus 1. And then we're going to substitute the numbers in. So we have 3 over 32 equals 3 times 1/2 and n minus 1. And we want to solve for n minus 1. So we are going to divide by 3 on both sides. So we have 1 over 32 equals 1/2 to the power of n minus 1. And to solve this, we can use logarithms, but another way to solve this would be to say that 1 over 32 is also equal to 1/2 to the power of 5. Because 1 to the power of 5 is just 1, and 2 to the power of 5 is 32. So this is going to equal 1/2 n minus 1. And because we have 1/2 and 1/2 here, we know that for this equation to be true, 5 has to equal n minus 1. So we have 5 equals n minus 1. So we have n equals 6. So there's 6 terms in the sequence. Okay, now here are some word problems. The first word problem is Milo likes biscuits. On the first day, he eats 1 biscuit. Each day after that, he eats 2 times the number of cookies. I meant biscuits. Okay. Okay, he likes cookies too, but I meant biscuits. He eats 2 times the number of biscuits he ate on the first day. How many cookies or biscuits did he eat on the 6th day? Okay, so on the first day, he eats 1 biscuit. And he eats 2 times the number, so R is going to be 2 because we're going to multiply 2 each day. How many cookies did he eat on the 6th day? So you want to find out what AN is when n equals 6. So I'm just going to write the formula. AN equals A1 times R to the power of n minus 1. And we want to find out AN, or A6, because we want to find out how much he eats on the 6th day. So A1 is 1 times R, and n minus 1 is going to be 5. So he just eats 32 biscuit cookies. Okay. Biscuit cookies. So that's how many biscuit cookies he eats on the 6th day. The next problem says, you drop a tennis ball from a height of 12 meters. After the ball hits the floor, it rebounds to 80% of its previous height. How high will it rebound after its third bounce? So we know that A1 is 12. That's the initial height. Then you might think that we want to find n equals 3 because it's the third bounce. But we actually want to find n equals 4. And this is because, let's say this is a ball and it's going to drop and it's going to rebound once, twice, and then this is the third time it rebounds. Oh, actually, no. A more accurate picture would look something like 1, 2, 3, something like that. Okay, so this is the first time it rebounds, the second time it rebounds, and the third time it rebounds. So this fall right here is going to be A1. That's the height. Then this is going to be A2. Then this is going to be A3. Then this is going to be A4. And we want to find out how high it will rebound after its third bounce. This is its third bounce. And so we actually want to find A4. So we're looking for n equals 4, and we want to find out A4. Okay, so R is equal to 80% of its previous height. So 80% is also equal to 80 over 100, which simplifies to 4 over 5. So we're just going to plug this in the formula. AN equals A1 times R to the power of n minus 1. So we have A4 equals 12 times 4/5 to the power of 4 minus 1, which is 3. So then we have 12 times 64 over 125, which equals 6.144 meters. So after it rebounds, after its third bounce, it's going to go up 6.144 meters. Okay, thank you for watching my video, and please remember to subscribe.